talked about Raman. They always talked about Raman. But Raman name is uttered at least by 1,000 or more than 1,000 researchers over the world. Because of what? Because Raman effect, Raman spectroscopy is so special, or so, is a lot of application. That's why people in the material science, people in the physics, people in chemistry, people in biology, all people, they use this Raman effect or Raman spectroscopy. And Raman spectroscopy has gone to a very high, level because of advent of lasers and all these. So this is, I think, even if you call Einstein, yes, Einstein, they teach, a lot of teachers teach in the class, but Raman spectroscopy is done by more than 1,000 students, 1,000 researcher students every day if you consider all the labs. So that is how we feel so proud about this Raman effect. And you have to remember, the only physicist that India has produced is Raman, who has got the Nobel Prize. Hopefully, this Science Day is a day where we give the publicity of science and to the young minds. And hopefully the students will come not only to learn science, but to apply science. And hopefully someday they will bring this kind of laurel, that is Nobel Prize, is something we expect from the students in future. With these few words, I think I over to Rupam. But before that, I once again welcome Professor Amitava Patra for his time.
Thank you, sir. Thank you. So now over to Deepshika. Deepshika will introduce our honorable speaker, and she is assistant professor in the Department of Chemistry. So please, Deepshika.
Thank you, Dr. Sen. I am very much welcome to our department, to our school. Good afternoon, everyone. I am very much honored to introduce our today's speaker, Professor Amitava Patra, sir, who is one of the eminent scientists in the field of physical chemistry. Professor Amitava Patra has received his PhD from Jadavpur University. After that, he did his postdocs from Japan. One is from Tokyo University and one is from Riken. Then he was in the Hebrew University, Jerusalem, and he worked as a research associate in the University of Buffalo, USA. Then after returning to India, sir has joined in Central Glass and Ceramic Institute, CGCRI, as a scientist. And then he shifted to Indian Association for the Cultivation of Science, that is known as ISCS, as an associate professor. After serving several years in ISCS as an associate professor and senior professor, now he has shifted to Institute of Nanoscience and Nanotechnology, that is INST, Mohali, and he is the director in INST Mohali. Sir has published many research publication. It is I am very junior to actually introduce him. He has citations of around 11,300 with a H impact of 57. He has received many prestigious awards, and some of few to name is MRSA medal, MRSA bronze medal, and the list is very long actually. CRSI medal, CNR Rao National Prize Award, and he is a fellow of National Academy of Science. So you can think how professor he is. Actually, with these words, I would like to request Professor Amitava Patra to start his today's lecture. Sir, please, this is all yours.
Oh, you have already taken 10 minutes.
Yes, sir. I am very sorry for that. Actually, I have approached him. I think you didn't remember me. Actually, I was a PhD student of Professor Pramanik. I approached you for the PhD at that time in 2007, but I couldn't join in your lab.
Okay.
Thank you, sir.
That is good for you. That is good for you.
No, sir. No, sir. I know that, but okay, sir.
So,
Thank you, sir.
Is it clear?
Yes, sir. It is visible, sir.
So first of all, very good afternoon and very this auspicious day, National Science Day. And I want to express my thanks to or gratitude to Professor Sanjeev Ghosh. I know him very well from long time. and also Dr. Rupam Sen and Professor Pandey over here, and other junior faculties or senior distinguished professors, those who are joining here. So it's my privilege that today I am able to give a talk in front of you. And when Professor Sanjeev Ghosh called me, that time I was a little bit hesitant because in our institute also there is program going on. Then I told that in afternoon, if it is possible, then I can do. Because this is the best important thing, because administrative part is different, but academic part is different. So anyway, I am right now in Nano Institute, INST, that I joined here in 2020, March. So this very young institute that is only 2013, it was established, but I came from the oldest research institute, that is cultivation of science. So I'm very, very glad to share something. The title, maybe I'm not comfortable with this, because initially I had a plan to discuss about the nano photonics. Then I changed my gear, because now, because of this day, I should discuss about the Indian science before independent and after independent. That is very important for young researcher. That will motivate all the young researcher and fellows over here. And last couple of weeks, actually, I was working on it and I learned a lot of things. So a lot of contribution from the Indian science. So the development of modern science, physics got formally established as a science subject in 17th century, but in chemistry in 18th century, end of 18th century. So you can see the first physics, then chemistry, then biology. And biology got the recognition after the Darwin came out with the history of evolution. Now the question is that for Indian science, when it is developed, most of the early development occurred in the modern science when the India was under the British. So during that time in 19th century, actually, and 20th century, there is a huge significant growth of Indian science. So some of the great scientists actually initiated the research work in the modern science in India during the British time. And they are really unforgettable, and they born in 19th century, that is J.C. Bose, C.V. Raman, Ramanujan, etc. And they are why we still talk about C.V. Raman, J.C. Bose, Ramanujan. Because not only for the science has a huge impact globally, but what is the impact of their service to the nation or for the country? That is most important. Sometimes we forget that we want to do some good science, we want to publish in Nature, Science, but this is not the end of the story. What people can remember you if you do something for the society or for the country, for the nation. That is the important contribution. That's why still we remember all these great peoples. In 20th century, there are a lot of big and brilliant stars in the science in India. They are majorly built, they are the SNT builders, we call, because they usually build the different kind of research institute, different institute for different places to grow Indian science. So these Indian leaders, these scientists, Indian scientists, we still remember because of the thoughts, because they have made our very nice, very big institute in India. So the history, that's why the history of Indian science is very enthralling subject, because it identifies the past institute, and the lesson in history helps the present and the future growth of our country or growth of any kind of research institute. Their philosophy, their character help to establish a new institute and flourish through the success and strategies. That is most important thing. That's why the history of Indian science is very important for for all the generation, especially for the young generation. Because any kind of growth, scientific growth for any kind of countries, for developed country, underdeveloped country, developing country, kind of thing depends on two important things. One is the scientific knowledge, other is skilled human resources. Because sometimes we talked about that any kind of advancement, scientific advancement depend the scientific knowledge only or the human resource. If we consider the human resource, we are next to China, but we cannot make that kind of scientific advancement because maybe unfortunately we cannot produce the skilled human resources. That is the lacking. This is in my perception. Scientific knowledge we have maybe, but we don't have that kind of skilled human resources. This is the lacking. That's why maybe we are not scientifically advanced what we should be. Now I'll talk about something that when our research started in India, before that, during the British time, British people has established couple of institutes only for their advantage, or they want to exploit the India completely, because they have issued the Survey of India 1766, 1781, Calcutta Madrasa, 1784, Asiatic Society of Calcutta, Botanical Garden, Banaras Sanskrit College, Trigonometric Survey of India. So all these issues, these are not the research issue, because that time they had the idea that India minds incapable of understanding the true science. They are always undermined the Indian people, and they always trying to exploit our Indian. So they have made different kind of issues during the British time. Now, when it begins, when that English education starts in India, 1817, when Raja Ram Mohan Rai established the Hindu college. In 1870s, it began the English education system in India. And the college was taken over the then government, that is British, in 1854, and that is renamed as a Presidency College. Right now, it is a Presidency College. So then, after 1817, then 1824, Sanskrit College at Calcutta, 1857, Calcutta Madras and Mumbai University, but there is no science, only the literature or different kind of subject, but no science subject. After 60 years, when Ashutosh Mukherjee, Sir Ashutosh Mukherjee was the VC, he started that postgraduate teaching and research during his time, that is in 1917, 60 years later. Now in 1904, the Association for the Advance of Scientific and Industrial Education was founded. 1906, the Dawn Society became the National Council Education. 1906, another for promotion of technical education. Calcutta Mathematical Society, Institute of Engineers, that is in Gokul Road, I think, in 1920, that was established. So far, this is the established only the university or colleges, no research so far. Ashutosh Mukherjee is everybody knows now. This is the prolific Bengali educator, jurist, barrister, mathematician. You know, he published first paper from India in 1881, and he was the first student to be awarded in dual degree. Right now, I don't know from Calcutta University they have given the dual degree or not, but that time, 1855, 1885, 1886, he got the 2 degrees. One is mathematics, other in physics. And he was a judge of Calcutta High Court during 1903 to 1924. Second Indian Vice Chancellor for Calcutta University. And he was taking a lot of responsibilities for foundation of the Bengal Technical Institute in 1906, that is the Jadavpur University in 1955, and College of Science, Science College of Calcutta University in 1914. So he has a major contribution for the growth of Bengal education system and also for the research. This is the Calcutta University. He served as a vice president of Indian Association for the Cultivation of Science, that is established by Mohanlal Sarkar, that is 1876. And he was elected finally the president of ISS in 1922. So he has a huge contribution for the National Library because his personal collection was 80,000 books he has donated to the National Library. He was first president of Indian Science Congress in 1914. He was the president of Asiatic Society. Then finally, during his honor to his birth centenary of Adamas Mukherjee, Government of India issued a stamp in 1964. So his contribution, enormous contribution for Bengal science, for Indian science. Then in 1916, Pandit Madan Mohan Malviya is associated with the Annie Besant, initiated the Banaras University. That is 1916. And that is the first comprehensive research university in India. That is. So that is not only university, that is now we are talking about the research university. Like in ISS also we are deemed to be university, but that is the idea is the research university. So mainly the MSc and research oriented kind of thing. So University of Mysore, Patna, Osmania University, Lucknow University, Delhi University is around 1916 to 1922. So all are universities that time, that is oldest university in India. Now the first birth of Indian Scientific Institute, that is by Mohanlal Sarkar actually. He was the founder of Indian Association for the Cultivation of Science. The foundation was the first research institute in Asia, that is cultivation of science, in 1876 in Bowbazar. And this picture is in Jadavpur campus, and that is the Jadavpur campus. I am from that place, and I am very fortunate. I am blessed. That's why I am still working there as a faculty there, as a senior professor there. My lab is still there. And interesting thing is that it is now funded by the DST. Initially, it was not funded by the government. I'll show you. So Mohanlal Sarkar, another personality that is in Bengal, he was a social reformer. He was a propagator for scientific studies in 19th century in India. So Mohanlal Sarkar was a medical doctor. Everybody knows that he was the second MD graduated from the Calcutta Medical College, 1863. And he started campaigning that Indian first scientific research institute, that is 1870. And ISCS was founded in 1876 after just 6 years, without receiving any fund from the British government that time. But in 1926, he received the fund, ISCS received the fund from the British government. So up to 1904, there is no research work, only lectures and something is there. In 1907, Ramon started research at the age of 19, and finally rest is history. That is, he received the Nobel Prize in 1930. So that is another research institute, that is IISc Bangalore. The very nice story, that is also another big, one of the best now, the research university. Now you see that is a deemed university, deemed research university. So this is the deemed research university. You see that during that BHU was supposed to be research university. And Swami Vivekananda, actually again Bengali personality, that Swami Vivekananda started they suggested the Jamsetji Tata during his journey from the Japan to Chicago. In 1893, he asked the Jamsetji Tata to make an indigenous research institute in India. And that suggestion actually became reality in 1908 from 1893. And then the Indian Institute of Sciences established by the Jamshedji Tata and wholehearted support by the obviously Maharaja of Mysore. He donated 350 acres of land and in Bangalore to set up the institute. So major Indian contribution in the 20th century because of the J.C. Bose, because of the communication and biophysics, Ramanujan, because of the number theory, Raman effect, small angle X-ray, acoustic optics, Bose, this is SN Bose statistics, Emin Saha, Meghna Saha, because of the Saha annihilation theory, Chandrasekhar because of the astrophysics. Now the question is that we know there's all these people, all these great people, they have contributed a lot in the 20th century to the global science on behalf of India. So the biographies of these renowned scientists of India are of the great interest since they paint a landscape of the times represented and along with the account of the scientific endeavors for the scientists concerned. So that's why I always go through their biography, and it is very encouraging, and you can learn many things, and you can train yourself by using their thought process, by using what they are thinking. So now I'll come to the Professor J.C. Bose. He is actually we call the father of modern scientific research in India. And once Nobel laureate Sir Mott described that J.C. Bose was at least 60 years ahead of his time, always talking, because beyond that time they discuss different things. I talk about. So J.C. Bose was born in East Bengal, now in Bangladesh, but obtained BA degree from physics from the St. Xavier's College. Later, he received the Typos Fellowship for Higher Education, University Cambridge. And they came back to Calcutta, joined as a professor in Presidency College, and he set up a very small lab next to the bathroom at Presidency College. Nowadays, we are looking for a 900 square feet room for set up our lab. Without lab, we cannot contribute, but we have to learn many things. Even in this limited condition, he obtained DSc degree from the University of Cambridge for his remarkable research within this small setup of lab, so near to the bathroom at Presidency College. Sir J.C. Bose's brilliant contribution across different fields, not only the physics, biology, even biology, botany, instrumentation, literature, education, and philosophy. So he was the inventor of the first solid-state diode. Decades before the semiconductor physics came to the realization. So he invented the aperture for generation of received the microwaves. In 1895, J.C. Bose demonstrated the world that such short wavelength electromagnetic wave can penetrate through the physical barrier like a wall and could be transmitted and received over the long distance, and that is the birth of the radio. That is the birth of the radio, television, everything, right? So he moved from the physics to the field of biophysics. I think he is the father of biophysics, a subject that biophysics is a subject that was almost that time, nobody knows that kind of subjects. So his research planned electrophysiology by inventing unique instrumentation to measure. He has made all these instruments for the bioelectric potential and quantify the tiny movement in the plant and simultaneously. That's why he established that the plants and animals have essentially the same fundamental physiological mechanism. So that time he discovered that kind of fundamental things that both have the same kind of physiological mechanism. In 1894, he first patented use a crystal that is radio wave detector in 1894 for the microwave experiment. Bose was patented at that time in 1901. We are now talking about patent and everything. And he was patented his first depth crystal detector in 1901. In 1895, the first public demonstration of microwave transmission in Calcutta Town Hall. His demonstration was the foundation of the technology used today. Everybody is using mobile, telephone, radar, satellite communication, any other application, any kind of application because of him. So we should salute to him. So this is that they have not done only the research. You see the contribution. Then he has established the Bose Institute. This is the building still now is there in 1970. So just after that cultivation of science, and it is a public research institute of India and also one of the oldest researchers. An interesting thing that it is now funded by the DST. This is also autonomous building. This INST is also DST institute. So already we have given ISCS Bose Institute because of the Bose, J.C. Bose. He established this Bose Institute. So this is again funded by the DST right now. These great person today's heroes. So Sir C.V. Raman, the first Asian scientist to win the Nobel Prize in 1930. And that is the beginning of the foundation of the scientific research in India. And this is the instrument still lying in our ISCS. Professor C.V. Raman used this very simple, innovative instrument. This is the part of the instrument, not whole instrument, which lead to the discovery of Raman effect that announced in 28th February today, 1928. And that's why we are celebrating the National Science Day. So what is his contribution? He was born in Trichinopoly, 1888, 7th November. After passing the FA examination, he joined Presidency College Madras at the age of 14. He first published first paper at the age of 18, that is in Philosophical Magazine, on unsymmetrical diffraction bands due to the rectangular aperture. So you can imagine at the age of 18, he published a paper in Philosophical Magazine. And right now maybe 10 plus 10 exam, maybe 16 years old or something. So in 1907, he came to Calcutta as the Assistant Auditor General at the age of 19. And then he quit, then he joined to the ICS, actually met the C.V. Raman. And C.V. Raman, not C.V. Raman, sorry, Asutosh Mukherjee. And Asutosh Mukherjee offered him a college professor. But college professor, there are two conditions that time, that you have to have a foreign degree, foreign training, and you have to teach. So Asutosh Mukherjee waived that two conditions. One is teaching and foreign, because C.V. Raman don't have any kind of foreign education. So, but he has offered him for a college professor. In 1930, Raman received the Nobel Prize that already talked about the ticket part. And 1998, American Chemical Society announced that is the International Historic Chemical Landmark. So, Raman effect. So Asutosh already talked about Raman sacrifice, that what he has written. I admire the courage and spirit with which Raman exchanged a well-paid official appointment for a university professor, maybe 1/4 salary. This example encourages me to interest the hope that there will be no lack of seeker of the truth in the temple of knowledge, which is our ambition to erect. So this is the statement he has given on Raman. So again, Raman has established an institute, that is Raman Research Institute, founded by the C.V. Raman, 1948. Again, this institute was now funded by the government of India, DST. This is another 3 research institute already, right? So they have not done only the research work, not publishing paper, not only that kind of thing. They have done something for the nation, for our country. So that part is lacking. So that is important thing to motivate our young generation. So he always talked about that Indian minds is not inferior. What we lack is our courage and a spirit of victory. If that determined spirit wait to arise, nothing can hold us for achieving our rightful destiny. So that is very important word for the young generation. Then another person, another big brilliant person, that is Ramanujan, because of monumental contribution in the number theory. At the age of 17, he started working on that. In 1914, he published only one paper, but he published 20 papers in 1915. So you can understand what is the huge contribution. Now in DST, there is in his name, there is a Ramanujan Fellowship is there. So people can remember this kind of giant or brilliant people in India. And Ramanujan theta function is always lies on the heart of the string theory in the physics, this Ramanujan theta function. So recognize the unique mathematical ability. He went to the Cambridge, but at very early age in 1920, Ramanujan breathed his last. So during the Manmohan Singh Prime Minister time in December 22nd, will be the celebrated for the National Mathematics Day to mark on 125th birth anniversary of Ramanujan. So these are the another persons. So again another personality, that is Meghna Saha. Meghna Saha, this is the Saha equation, maybe, but if you go to the Calcutta in ISCS, you will find out this equation in his statue. He was the first director of ISCS and founder of SINP and INSA. He was a Khoira professor in physics, moved to Allahabad University and established the physics department as a center of research. Again, he returned back to Calcutta in 1938 as a Palit professor when Syamaprasad Mukherjee, the son of Ashutosh Mukherjee, was the DC. He obtained 60,000 rupees that time, 60,000, 1938, obtained 60,000 rupees from the Tata Trust to build a cyclotron to initiate the research in nuclear physics. Still, we don't have that kind of cyclotron center over here. So I'm not talking about the FRS because all people are FRS during that time. So 1919 was the productive year for Saha, and 3 papers he published in Philosophical Magazine, on Physical Review and Astrophysical Journal. On Maxwell stresses, this paper was based on the studies of electromagnetic theory of radiation. Then another theory has established Febvre period interference, new theorem for elasticity, dynamics of electron, pressure of light, influence of infinite volume, that is joint paper with H.N. Bose, on the mechanical electrodynamic property of the electron, that is in Physical Review, on the radiation pressure and quantum theory, that is Astrophysical Journal. So on the fundamental laws of the electrical actions. So Saha was not only doing the great science, great science, he founded the National Academy of Science. Allahabad is the oldest academy of India. Indian Physical Society, Indian Science News Association. He started the National Planning Commission, Planning Committee of the National Science Congress, 1939. And he was elected as an independent candidate for the Lok Sabha in 1952 because his major contribution for the Bengal is DVC, that is Damodar Valley Corporation, to control the flood in Bengal. Suddenly heart attack in 1956 during his visit of Planning Commission in New Delhi, because we heard that at that time he had a file of ISCS file for the new building or new construction, and he had that file. He went to the Planning Commission for some meeting. So a stamp was released to honor him at his birth centenary in 1993. So Saha stated that scientists are often accused of living in the ivory tower and not traveling their mind with realities, and apart from their association with the political movement in their juvenile years. And I had lived in the ivory tower up to 1930. But science and technology are as important for the administration nowadays as law and order. And I have gradually glided into the politics because I wanted to be of some use to the country in my own humble ways. So that is the different approach. He has want to contribute to the country by using that science and technology policy maker or something. So he's a huge contribution on science and also for different institute building. So this is the Saha Institute right now, the Saha Institute of Nuclear Physics. It was established in 1949, and Sama Prasad Mukherjee that time was the Minister of Civil Supplies and Industry in Nehru's National Cabinet, and that was established the Indian Institute of Nuclear Physics. Then it came to his name, that Saha Institute of Nuclear Physics. Then Satyam Bose was born in Calcutta. He was a student of J.C. Bose and P.C. Roy. In 1915, he was graduated in the top of the classes. He is well known for mathematics and physicists, especially the theoretical physicists. He is the best known for his work quantum mechanics, Bose-Einstein equation, and Bose-Einstein condensation, and so boson. So he had a wide range of interests in varied fields, including physics, mathematics, chemistry, biology, mineralogy, physiology, arts, literature, and music. And he served many research papers, many research and development, different committees, in national committees. He was, and the government of India established another DST institute, that is SN Bose National Center for Basic Science in Salt Lake, that is established in 1866. It is now government again by DST institute like us. So already 3-4 institute is there. So he worked as a Madame Curie with Madame Curie in France, and worked with Berlin also with Einstein. So he has a lot of paper published with Magnus, many things, and he has was elected a Fellow of Royal Society in 1984. He died in Calcutta at the age of 80. So he was internationally recognized because unfortunately Nobel Prize was denied to him. So now, so far we have discussed about the physics, but now the chemistry begins in India. Prafulla Chandra Ray, he is considered to be the father of the chemistry in India. So P.C. Roy was born in 1861 in Bangladesh. He came to Calcutta, and P.C. Roy's main contribution in inorganic chemistry deal with metal nitride. He was the first to make the mercurous nitride and ammonium nitride. So he was noticed that reaction between mercury and dilute nitric acid resulted in the formation of yellow crystalline solid. So he is a huge contribution for the chemistry, and he is the father of chemistry in India. Before that, all physics people are there because they are, and he is the only first person in India that he established that pharmaceutical company in India, fast pharmaceutical. That is, we are now talking about the startup company. We are talking about the business. So he has done during 1901, that time that Bengal Chemical Pharmaceutical still is there, right? In 1924, Indian Chemical Society was established. What is a huge contribution for the growth of our country? He was the hero in chemistry. So he was the leader for Indian science journey in chemistry. So after independent taken initiative to reform the higher education system and science and education or technology in India. To promote technical education, so far there is no technical institute is there. So 12 to 22 members committee of scholars during that time, that first IIT established in 18 August, that is 1959 in Hijli jail, then subsequently Bombay, Madras, Kanpur, Delhi. So these are the first science for technical education center. In early 60s, that all the NITs, now initially it was the regional engineering colleges, now it is NITs, that was established 1960s. And 1960 is very important year because that time that close ties with Soviet Union for Indian Space Research Organization rapidly developed by Indian Space Research Program and nuclear power in India even after the first nuclear test explosion in India on 1974 at the Pokhran. Now the policy, the government of India has passed a couple of policies. So far, 4 policies documents are available for science and technology. One is Science Policy Resolution, that is 1958. Technology Policy, that is 1983. Science and Technology Policy, that is 2003. Science, Technology and Innovation Policy, that is 2013. And recently the new education policy, that is 2020. So that 5th policy is already passed. So, and what are the science academics in India? There are 3 academies, that is Indian Academy of Science, established by C.V. Raman in 1934. Indian National Academy of Sciences, that is established by the Meghna Shah, 1930 in Allahabad. Indian National Science Academy, established in 1935 in the New Delhi. So the new architect in the post-independence era. So S.S. Bhatnagar, M.N. Saha, P.C. Mohali, J.C. Ghosh, and Homi Bhabha, they are the architect. They are the architect for different kind of research institute and for our country after independence. So P.C. Mohali established the Indian Statistical Institute, and it is famous for the Mohali model. And he has started the Sunkha, that journal. And it is well known that we celebrated the National Statistics Day on his, the government has decided on his birthday, that is 2006 onwards. So again, K.S. Krishnan is another important person because he worked with C.V. Raman. Then he moved to the Dhaka as a physics reader, where Satyan Bose was head. Then came back again his main work on magnetic anisotropy of diamond paramagnetic crystal. Then he came back to the Calcutta, and MLS professor Mohanlalal Sarwar still is their chair professor in physics in ICS. In 1948, again moved to the Allahabad University for a head of the department. And again, Bhatnagar, S.S. Bhatnagar invited him to the founder director of NPL, that is the NPL in 1947. S.S. Bhatnagar is from Punjab. Bhatnagar is the extraordinary planner and architect of the chain of national lab. All CSIR labs established by him in presence in the guidance of Nehru. So Santi Saru Bhatnagar was born in 1894. He is a chemist. He is a magnetochemist. So his work is magnetochemistry. Bhatnagar actually joined and BHU as a professor, then came back again to Punjab University, was elected Royal Society Fellow 1943, and that's why the CSIR had coveted the Science Award of CSIR, that is Santi Saru Bhatnagar Prize. In 1943, the CSIR was established. This is the CSIR and all the national labs in different part of the country. That's why we call the father of research laboratories. There's another extraordinary person, that is Bhabha. Bhabha established that TIFR, that is Institute of Fundamental Research, in 1945, and that is finally and Bhabha Atomic Research Center, 1954. And there is very nice quote from the Bhabha. for all the students. My success will not depend on what A and B thinks on me. My success will be what I make of my work. That is very important thing for the young generation, because most of the time we always think that what A and B, what A professor or B professor thinks of me, that depends. That does not depend, because you have to be criticized, you have to be judged by other people. But if you want to do something extraordinary, you don't care about that. So these are the important to research institute because of this Homi Jahangir Bhabha. He was very well-to-do family. He was after Cambridge education, he joined IISc Bangalore. Then Bhabha proposed the idea to setting up the atomic energy, and Bhabha primarily responsible for setting the Indian National Committee for Space Research with Sarabhai Vikram. And he died unfortunately by plane crash in Mont Blanc in 24 January 1966. That is on at the age of 57 years old. So the country honored him by naming the Atomic Energy Center in Mumbai as the Bhabha Atomic Research Center. So again, another space person, father of Indian space program, that is Vikram Sarabhai. Vikram Sarabhai was born in 1919. After education in schooling from Ahmedabad, he went to the Cambridge. Then he joined to IISc Bangalore as a student of C.V. Raman. Then again returned back to Cambridge, then came back, and he was set up the first rocket launcher station in Thumma near the Trivandrum with the Homi Bhabha. First flight was launched in 1963, Indian Space ISRO, that is 1962. They are the major achievement of Vikram Sarabhai. So that's why people are saying that space program, father of Indian space program. So again, another research institute was established, that is in national, that is the Physical Research Laboratory, that is under the Department of Space and Government of India, that we call PRL, that is in Ahmedabad, that is by the Vikram Sarabhai. There is one unhonored and unsung person from Calcutta, that is Sombhunath De. He is FRS that time. He actually discovered the cholera toxin, but he was nominated several times for the Nobel Prize. Okay, unfortunately, didn't get it. But De was never elected a fellow of Indian academies and never received any major awards from the India. That's why we call Professor P. Balaram pointed out in his editorial comment in the Current Science that Sombhunath De died in 1985, unhonored and unsung in India's scientific circles. So that is very unfortunate part, but his contribution people remember because of the cholera toxin. There is another person, very outstanding scientist in the current generation, that is G.N. Ramchandran. After post-independent, he worked a lot of things because Ramachandran plot, you may be those who are doing biology. Ramachandran was the dominant figure. He was a brilliant scientist in 20th century during his pioneering work on the field of protein structure, molecular biophysics unit. He was in IISc Bangalore. So he was a student of C.V. Raman and well-known Indian biophysics. He was first triple helical model for collagen structure. He has done a lot of extensive work on peptide-related structure. He has become the essential tool for the find of protein conformation. Ramchandran studies many topics related to peptide conformation, including type of beta turn, conformation of different kind of peptides. So he was nominated several times for Nobel Prize for his fundamental contribution in protein structure and functions. There is another great person in our time. You can say that his most important contribution, that is Rai Chaudhary. So Amar Rai Chaudhary, he is an important contribution of Rai Chaudhary's equation, because in 2020 Physics Nobel Prize after Penrose discovered that to black hole, that Rai Chaudhary's equation is general relativity. Actually, that equation he has published in 1955 for a mathematical description of black hole in 1969. Even though the general relativity was predicted their existence, Einstein himself did not believe in them. So Raychoudi's equation is famous after the Penrose and Hawkins when they received the Nobel Prize in 2020. So he's from the Calcutta. So we should be proud of him, Raychoudi's equation. In the last scientist, I always salute to APJ Abdul Kalam because of his contribution for the country. He was born in Rameswaram, graduated Madras IT, Madras Institute of Technology. Then he joined to DRDO. Then he moved to the ISRO. He was a project director for SLV-3 and Rohini. And Pokhran 2 test, he was the main role. Kalam was elected 11th president, and he was referred to as the people's president. The important quote that I always share with my students, that and all the colleagues also, that if you salute your duty, you no need to salute anybody. But if you pollute your duty, you have to salute everyone. Fantastic statement by the Kalam. So that's why everybody should do their own duties. So you don't need to care about who is boss, who is other things. So now I'll come to another topic, that is for the scientists, and what is the life of the scientist for the young generation. For a scientist, the creativity, originality, imagination, intuition, persistence, ability to collaborate, depth and breadth of the subject, humility, and the honesty is very important for the scientist, for a good scientist. Life of a scientist is full of stress, rejection. Rejection means, paper rejection, something rejection, intense competition nowadays, and politics obviously there. And most important thing is the balancing between the family and work. That is very important. How do you balance the life? The 5D to success, always I talk to my students that you first have a good dream, direction, desire, discipline, and determination. 5D is very important for any kind of success. And all the creativity comes on the subconscious mind. If you are deeply immersed and committed to the topic day after day, your subconscious has nothing to do but to work on your problem. No ideas often seem to be pop up when the mind is idling. So always you have to think, you have to create, you have to do something. Don't compare with anybody. So another, choosing the research project is very important thing, because most of the time we publish a paper after getting some facts and more facts. That is not the important thing. Great contribution rarely comes by adding another decimal or place. If you, instead of boring or something, you should not do. Young scientists should aspire to become established within a particular discipline. Find a project that could be identified as your field, right? So as a man of like space person or Einstein equation, that's why we know them, that scientists. And right place to work is very important for the young people, because you have to join in such an institute that there is open mind and seek out a place, and they should be surrounded by first class intellect so that you can interact with the people. And as a scientist, your chance of achieving anything can be greatly reduced by joining an institute that is under resourced financially or does not value the creativity. So our 4 points action plan to evolve the scientific recognition, that is emphasis on great science, teach the science, outreach the science, and inspire the people so that they can come to our subject, showcase the leaders who go beyond their day job and open up new ideas, extraordinary opportunities in science, celebrate the scientific breakthrough that transform our understanding of the world and resolve some major issues. That's why teamwork is very important, leadership is very important, professionalism is very important, and diversity is very important. No emotion. Make you strong, make you confident, make you fearless. The hardest work in the world you make alone. Ekla chalo rahi. The sun is alone, eagles fly alone, lions are alone, but they are very powerful. So you have to be alone. So if you want to be powerful, if you want to be hardworking guy, you have to go alone. You will not find out anybody who will help you. So I'll talk a couple of slides on nano research, that is nanophotonics and biophotonics. This is my field. So what is the big challenge in the nanoscience? We have witnessed the phenomenal growth as well as the impact of the diverse area of nano research over 3 decades, because it occupies now a central stage of all science, biology, physics, chemistry, engineering science also. So major happening in 2004 was the discovery of graphene, which gave a new direction, that is the 2D structure. People are thinking about the 2D structure now. Nobody is working on, very less people are working on quantum dot or something. We cannot forget the world of nanoscience extends several important areas: energy, environment, agriculture, and medicine. I have been truly impressed by the contribution of the nanomedicine, including the strategy of cure cancer. I hope it will be possible to recover some detection strategy for lung cancer, Alzheimer's disease using the nano nose. So there are the important activities in our institute. That is one: energy, environment, healthcare, agriculture, and quantum materials. To this notion, the institute brings together the biologists. We have all the biologists, chemists, physicists, and material scientists over here. This is an interdisciplinary research institute, and our focus is to understand or to resolve some societal problem or global problem by using the nanoscience under the same umbrella, so that our interest on nanoscience and technology, not only science. In a short span of 7 or 8 years, INST has created a state-of-art facility to support the multifaceted research activity in our campus. So in young students, they don't know what is nano. So what is nano? Nano is the manipulation, design, and engineering of matter in nanoscale. So if I compare with the DNA has a 2.5 nanometer in size, because nanometers mean 1 nanometer is 10 to the power minus 9 meter. So human hair is likely black hair, especially the 50,000 to 180,000 nanometer in diameter. The sheet of a plain white paper is 100,000 nanometer thick. So you can imagine, you cannot see the nanometer size in naked eyes. You have to use the transmission electron microscope. So if you multiply 10,000 with 1 DNA, then you will get the diameter of a bacteria, that is 2.5 micron. Similarly, single wall carbon nanotube, if you multiply 100,000, then you will get the stand of a hair, so diameter of a hair. So why nano is important? That is superior property than the bulk substance. It can enhance the mechanical strength, thermal stability, catalytic activity, electrical conductivity, magnetic property, optical property, because
I'm using my laptop while charging.
high surface to volume ratio, quantum confinement effect, wide range of application, that is quantum, electronics, nonlinear optics, photonics, sensing, informative science, processing, different kind of new field, nanofabrication, nano device, nanobiology, nanocatalysis. So these are the different applications. This is a recent review article in Science. You can use for bioimaging, you can use for drug delivery, you can use for energy harvesting, you can use for display devices, for any kind of application. People are now using this nanomaterial because a huge potential. So in our interest is in nanophotonics. Nanophotonics deal with the photon energy, because photonics, why photonics? Electronics photons is much faster than electron. That's why we want to use the light to make some devices, that is photonics, that is nanoscale optical science and technology. And biophotonics is the interaction of the light with the biological matter, that is photonics with biological thing. Sometimes we use most of the cases single photon absorption, because if you excite by the lower wavelength, you will get the emission in the higher wavelength. But the problem is that lower wavelength is huge energy that will destroy your cell. That's why two photon spectroscopy in our work we use, that is the upconverted nanoparticle, where two photon absorption process takes place and one single photon emission that can be used for the cell imaging purpose, that is deeper tissue penetration, because NIR light we use for less tissue damage, long lifetime, because of the rare earth diode laser you can use. You don't need any high ISFL laser, expensive laser. So these are the nanomaterial. We work on it for the bioimaging or fluorescence imaging by using the two photon spectroscopy. So nanophotonics deals with the optical science and technology. It can be divided in nanoscale confinement of radiation or nanoscale confinement of matter or nanoscale photophysics. We are working mainly on this for nanoscale photophysics or nanoscale confinement of matter, that is nanoparticle. Most of the people are working in this range. So there are a lot of strategies people are working on for light harvesting system, 2D material, perovskite, metal cluster, upconverted nanoparticle, quantum dot semiconducting nanoparticle, carbon dot, conjugated nanoparticle, inorganic hybrid metal nanoparticle. These actually, in fact, we are working everything in our lab. I'll not discuss on these scientific things today. So these are the activity in our lab. We are working on rare earth nanoparticle for two photon spectroscopy, quantum dot mainly for decay dynamics, ultrafast spectroscopy, protein nanoparticle interaction, DNA nanoparticle interaction, polymer nanoparticle based system for bioimaging, or porphyrin polymer nanoparticle for light harvesting, dynamics for the confinement, metal cluster for aggregated induced emission, nonlinear optics. This is the nonlinear optics by using the metal cluster, carbon-based nanoparticle for relaxation phenomena, or carbon clusters for different kind of photophysical properties. So the basic concept in nanomaterial, in quantum dot, in bulk semiconductor, there is a valency band and conduction, but when you reduce the size to the quantum confinement effect, then what happened due to the density of state over here is very low at the band edge, the density of state increases rapidly above the conduction band and below the valency band edge. And then it can be line up that is limited atomic like structure. And the expression for the band gap will change, that is the effective band gap will change with the confinement effect and the Coulombic rate. So by changing the size and shape, you can tune the band gap. So by reducing the size, you can increase the band gap, because here R is inversely proportional to the band gap. So if you increase the R, so band gap will change. So that can be, it is a particular in a box, that kind of concept we have. So what happened when you put the light, you can generate a light, put a light interaction with the nanoparticle solution. This green light you can change from blue to red by changing the shape of the size of the thing. And important issues in our lab, we are working on decay dynamics, exciton plasmon interaction by using the ultrafast spectroscopy, protein nanoparticle interaction. So what is the why this emission comes? This very simple process. This is the valency band and conduction band. When the light comes, it will interact with the valence electron. It goes to the conduction band. And if they will recombine, they will generate a light. That is the emission, that is the radiative path. But in that case, one photon absorption, one photon emission occurred. That means the quantum will should be 1. But in most of the cases, in generally, the quantum is less than maybe 0.5, 0.1. What is the reason? The reason is very simple, that after the conduction band, it goes to the trap state or defect state. They will recombine non-radiatively, they will not generate light. So there is always a competition between the radiative and non-radiative path. So I'll not discuss all this, but this is our research work. We try to understand all the kinetics, how it happens, and how that will help to make our new materials. So the important issues right now we are working, because that is the energy issue is very important issue, because 80% energy is coming from the fossil fuel. So now, right now, the global energy consumption is 16.3 terawatt. It could be reaching to 40 terawatt in 1950. So people are desperately working for the renewable energy. Another important issue is the global temperature, because because of the carbon dioxide, and people are trying to reduce the carbon dioxide. Different kind of catalysis people try to develop. So carbon dioxide level is 590 ppm right now, raised up to 590 ppm. That goes to the 2 degrees centigrade. That will change the global temperature. So that people are desperately looking for single atom catalysis or different kind of nano catalysis to reduce the carbon dioxide. So the major challenge in the solar cell application is this, because this is the solar spectrum, because 33% energy losses due to the thermalization process in case of solar cell application. So now people are trying to understand what is the thermalization process. How do you remove this thermalization process? Is very try to understand very simple way. This is the valency band and this is the conduction band. When you excite the light, not in single wavelength, right? You can have the UV light, you have visible light, NIR light. So this electron goes from the valency to the above the conduction band. And above the conduction band, that electron goes down to the conduction band. That is called the hot electron. And that excess energy will change your phonon vibration, that will heat up your system, and that kill you. That is called thermalization process. So before coming over here or reduce the thermalization process, people are working different kind of substrate. We are working to understand, because it takes less than 1 picosecond time scale, less than 1 picosecond time scale. That means 10 to the power minus 12 seconds. So you can understand. And that's why our solar cell energy consumption efficiency 31%. It could be 66% if we can reduce the thermalization process, because thermalization process 33% losses due to the thermalization process. So people are working on extraction of hot electron. We are working on different kind of system. So optoelectronics application, that is LED light emitting devices. What happened, that electrical energy convert to the optical energy through the energy transfer process. But in photovoltaic or solar cell, what happened, the optical energy converted to the electrical energy through the energy transfer process. And that's why the sunlight is very important for the solar cell. Solar cell and photovoltaic is, you generate electron and hole, you extract that electron and hole, and you can generate a photocurrent. So that is the most important thing. What kind of material you will choose? You have to choose the exciton binding energy should be less, exciton diffusion length should be high. So these are the couple of mechanisms. What kind of material is good for the solar cell or photovoltaic cell? So in quantum materials, people are working thermoelectric, SARS, Weber electronics, renewable energy, microfluidics. This is in our issue. In nano bioactivities, people are working cancer, nanomedicine. I am not expert on this. Biomimicking, tissue engineering, agri, nanotechnology, nanotoxicology, nanodiagnostic, nanotherapeutic. People are. This is our institute performance. Cancer nanotherapy, people are working here. Very nice team. They are using all the nano active materials for cancer nanotherapy by using magnetic nanoparticle for cancer cell protein nanoparticle. These are the different activities in our institute. So nanotherapeutic people are using for tuberculosis by pulmonary delivery, not oral drug. So hybrid nanostructure for dyspnea. So tissue engineering, drug delivery, self-healing, hydrophobic coating applications. These are the few technologies in our institute we have developed, that is the air pollution filter system by using the nanomaterials, low cost water purification system development for enamel coating by using the nanomaterial for jewelry. These are the companies for, so this is the Titan company. So these are the few important contributions from our institute. So finally, I must thanks to all of you for patience and knowledge. And this is our institute. This is our new institute. This is Institute of Nanoscience and Technology. And I welcome all of you to come over here to, and even for your student, they can apply for their project. Because last year I have already signed a MOU with Rohada, with Belur and with Narendra, so that every year they come to our institute for master degree for 2 months summer project. So thank you very much. So
Thank you, sir. Thank you, sir, for your excellent lecture. It enriched all of us through the memorable journey of past science in India. I'm sure that there are many pertinent questions to be asked. And for that, I am introducing Professor Nabkumar Mahato, who is the Associate Professor and HOD of Mathematics, Department of Mathematics in our school. And now it is over to you, Professor Mahato.
Thank you, ma'am. Thank you. Good evening to all of you. And now, as Madam has already mentioned that just now we have covered the talk by the Professor Amitava Patra, sir. Now, please audience, if you have any query, please ask directly or you can write down in the chat box. Any query from audience? Sir, if there is no query now, I have a small query. Now, as all of you know that we are now in post-COVID scenario. So what kind of mindset has changed before COVID and after COVID in the research area?
Very nice, pertinent question. I can tell you from our point of view, in INST, not a single day we have closed our institute. In old campus, initially first 3 months I closed down. That time I was alone here. But next second round, we never close it. And in our institute, we don't have that kind of issues. Second thing, it's a mindset. If you want to do something, is any publication, journal is lenient to you if you send a paper? They will not, right? They will go through their proper way. Is any reviewer is not reviewing your paper due to the COVID? No, right? During the COVID time, everybody paper published in Nature, Science. Any issue has stopped due to this. So it is our mindset, obvious. Even you forget about your COVID situation. Research, I'm talking about research. I'm not talking about the BSc, MSc classes. I'm talking about the research. It's a mindset. Even if you are a very good condition, weather good, everything, you may be sick, right? That time also it can be happen. So I think that will not stop your growth. So I don't think so. I don't think. Sometimes it can be slowed down. It cannot be stopped. It can be slowed down. Maybe initially you publish paper, 3-4 papers, maybe this year, maybe 1 or 2 papers, or 1 hona chahiye. That should be. That should be. There is no excuse. After 5 years, people will forget about the COVID. Even this situation, those who are graduated or something, oh, you are the COVID batch. Okay, what is that? They will give you less salary or high salary, anything. That will not affect. That will not. Science will not stop. This is our mindset. Even this is the bad thing, because you cannot open your lab and all the time excuses that our instrument is not working. Last 1 year it is not working. So it is again you have to apply to the administration. We have to give the money for fixing our instrument. But I think Obviously there is, but you don't think about it. You don't think.
Okay, sir. Thank you very much. Sir, anyone?
Pato,
Yes, sir.
I have one thing to mention.
Okay, sir.
Amitava,
Yes.
this is a very, very nice lecture, starting from, the beginning of science in India and then going through your subject. And these are modern topics that you're talking about. I just want to mention one thing. When you talked about Professor Saha, Meghnad Saha, all my students present here or faculty should know that Meghnad Saha not only was a scientist, as mentioned by Professor Patra, he was with the Planning Commission, DVC and everything. And with all of this, he wrote a book, Treatise on Science, Treatise on Heat, which is the best book in thermodynamics.
Right.
Saha and Srivastava.
Right.
And the modern best book written by some, for example, Zimansky, they actually, cited this book. They helped this particular book helped them to write this book. So think of, sometimes teachers say we don't have time to write a book.
No,
Sometimes teachers say don't have right time to publish a paper or research. So everything goes simultaneous. I mean, teaching, research, scientific ability, and then everything, societal activity, everything can go. All things can go simultaneously. So Professor Meghnad Shah was an example for that. So students should know this. And one more thing.
Yeah.
Yes.
No, actually that will motivate you. That's why you could not think why it is not done. Because you have to think we are in India. We cannot compare with other. But why we are always negative? All the people are saying that because of this I could not, otherwise I can do anything. No, this is not.
Right.
This is
Right.
the.
And one more thing, he mentioned about the missile man, our president.
I respect.
Yeah, everybody respects him. Actually, one time I invited him, and he told me that please invite all the students from surrounding schools, because
Right.
I love to teach. I love to talk something in front of the young minds.
Right.
And he mentioned one thing. You mentioned something. I remember he mentioned one thing. He told that the word fail, F-A-I-L, it will come to your life many times. But the word FAIL means first attempt in learning. He told us the first attempt in learning. Fail means this. So failure will come in science, in everywhere in life. But don't think that is a fail. It is the first attempt in learning. And this is the what is like a Bani of the statement made by Abdul Kalam Azad. Yes. Thank you again, Professor Patra, for
Thank you very much.
accepting our invitation. And I think, as Professor Pandey mentioned all the time in our lectures, that if our faculty members or students want to collaborate, I am sure that your lab and your institute will be open to us.
No, if you want to write to me that if you want to MOU or something.
Yes, that's what you want.
For,
Professor Pandey, can you
can
say something about this?
I can do it. You can think about it that every year 1 or 2 or 3 or 5 students you want to send for summer student or something, we'll accommodate over here. We have no problem.
Yeah,
we'll arrange the local hospitality also. Staying hostel inside the campus. Last year I signed with the Belur, Narendra and Rohada. Last time they came 15 students. And in COVID time, last March, April, May, they came over here.
Sir, that would be a great help for us.
This is not help. I am not talking about help. Everybody, you are a director. I am a director HR for the 5 years. This is the responsibility.
Yes.
If you always talk about the responsibility, then your mindset will change. If you talk, I am a director, I can sign, I can give mine, this mindset actually kills us.
Yes.
Our responsibility, what is our responsibility? Not for our young generation. If I can do, I can do. I will sign every time I ask my, no sir, nahi hoga. I know phasi mein de dunga, de de. But I will do for myself, not for myself, for the responsibility. I will do it. I don't care about this part. I can go to my ICS lab. I have no problem. I have no problem. I am not like a film star ka director ka backside there is a routine directors, right? I don't care. Oh, vanity hai. This actually kills us. This actually kills us.
So Dr. Rupam will get in touch with you, sir.
Sure, sure.
And actually, that's true that very few people think this help as responsibility. So we are really honored to have you, sir. And most of the time, whenever we are discussing about MOU, we feel and face the same thing. Okay, Dr. Pandey, I will help you in this. Dr. Pandey, I'll help you in this. So I have now.
Last week I went to Guru Nanak University last week. Then I told him that why your people are not visiting our institute or summer. No, sir, the initial director interested in immediately send karo. I'll sign it. They have not sent it yet. I told him send karo immediately. I'll sign on that day.
So, Dr. Rupam.
Yes, sir. We are ready.
We will never get, such type of.
You cannot run like me. You cannot. That I can assure. Here also, all Punjab people also said, you are so fast. Abhi finish karna chahiye. You have to finish the thing, then only you can take the next thing, right? And if you hold one thing for only one MOU sign or MOU sign, bilateral thing, something with Russia, China. What is this? A student, a government money. We are using the government money.
Rupam, Amitava will take only nanosecond. Sign. You only take
now I am doing
nanosecond.
femtosecond. Now I am doing
Okay. You will take nanosecond only.
Right.
Okay, sir, I'm preparing the document.
Sure.
Yeah, please.
Ask you, what is your plan? You write down.
Yeah.
And
Internship as well as collaboration. And since your institute, have physicists, chemists, quantum mechanics people, theoretical people, biology people, so it would be a great help not only for School of Science but also School of Life Science and Biotechnology that we have.
Science, there are a lot of good faculties are here. They are really doing very good, and all the facilities are here. All the facilities.
Onek dhanyawad, sir. Looking forward to see you. Thank you.
Thank you, Sanjit.
Thank you.
Okay,
Thank you,
sir. I think one participant, Koshani Roy, would like to ask one question. Koshani, are you there?
Internship, regarding internship.
The same thing. It has.
Yes, sir.
Where is your? I want to see. You are in mobile or in laptop?
Sir, I'm in mobile. I'm doing from mobile. Good morning, sir.
You are from the college or from the outside, from the mall?
Sir, I'm from the college, sir.
So I want to see you. Can you open?
But yes, sir. But now I'm not in college, and now I'm in home.
Dekho. That's why I ask you. This is the problem of virtual meeting. If you are really interested in which field, I don't know, you write to me directly. What you want to do, you see our profile, faculty profile, not to me. I'll assign him somewhere. If you are really interested. But mobile, nahi chala. If you are really interested, then I will encourage you.
Sir, I am really interested, sir, because there is some issue with my laptop, so that's why
in which field you are working?
Sir, in chemist field or any lab work.
No.
I am in chemistry field. I'm in chemistry.
Chemistry. No problem. You check our website, Energy Environment Group or Bio Group or Self-Assembled Structure, Organic Thing. You just point out, if you want to do research, you have to focus. What you want to do. First, you have to identify what is your strength, what you want to do. Because I can give you potato, onion, fulgobi, everything. But you have to know whether you go for fried potato or with curry with something. So first,
Yes, sir,
decide,
definitely,
first
sir.
decide karo. Then write to me. Then I'll give you chance. No problem.
Okay, okay. Thank you so
I'll
much.
arrange
Sir.
it. I'll arrange it.
Thank you, sir.
Thank you so much, sir.
Kausani, are you there?
Huh?
Kausani,
I think question is not in the meeting now. Okay, so any question from other audience?
See, most of the students now, they will not write anything because they know sir is asking to switch on their camera. So,
No, that is the reason. No. That is
I have one queries.
Yes, sir.
Is it audible? Is it
Yes, sir.
audible?
Yes, sir. Yes, sir.
Yes, sir.
Okay.
not visible, audible only.
Feasible. You want to see me
Yes.
here?
Hey, so
You recognize me?
yes. You are there. You are there. Oh.
So from the beginning, I'm trying to contact over you to say something, Amitava. So really, I'm really happy that you are in a position at INST. So really, congratulations.
Position is ठीक है. Position हो इधर है.
So as you say to the students, Amitabh,
Yes.
Amitabh,
Yes.
as you say to our students that if anyone is interested, so please write to the office through the website in which area one has to get some interested.
Right.
So this is very good initiative for your institute. Like when we were in the CGCRI, so this type of MU and all this corresponding the work, even by MTech students, they are working in their project work with the CGCRI. Okay, so this should be maintained all through.
Yes.
I think, yeah, this should be maintained. So I think that I must
That's
request
why
to
I asked
Professor
the
Pandey.
student. That's why I asked the student if they send me, I want to do some intake program over there, internship.
Yeah.
Then to
Yeah.
whom I will send? They have to